Hello everyone. First of all, calm down. I know you are scared because this is TOC, Theory of Computation, and many people find this subject very fearful and difficult. They don't know how to study this, and it is separate from the other subjects, right? In other subjects, you get a set of super important questions. You will be studying just those, and same questions might come in exam, and you will get the marks. But in TOC, it's not about super important questions, okay? But it's about understanding the topics and methods, okay? So I'll be telling you what all you need to know from the understanding perspective to clear this subject in the first attempt, okay? So first of all, go and bring a pen and paper. No, I'm not joking. Go and grab a pen and grab a few sheets of paper and come. Okay, otherwise not be able to follow up with this video. You can close this video. Okay, it will be of no use because TOC is all about practicing questions. Okay, I'll be telling you what all you need to do, when you need to do. So if you follow me along, you will be easily able to complete this video along with me only. Okay, need not practice anything separately. That's why I'm telling you. Again, yeah, I know you haven't got a go and bring pen and paper. Okay, fast. And I'll be telling you what all you need to know, A to Z everything. If you don't know about TOC anything, you have to listen to any class. It doesn't matter. In this video, I'll be taking you from the basics till the most advanced question which has come in the paper. Okay. So without wasting time, let's get started. But before starting, please do like and subscribe. It helps to make more videos like this. And share this video to your classmates in your class group. It will increase my reach, which will help me to make more videos like this. Okay, so I'll get to know that it is a useful video. Okay, and if you have any doubt, you can DM me on Instagram here. If you want the PDF, you can DM me on Instagram here. Okay, so let's get started. The first module is three topics here, which are the most repeated ones. Okay, see, in exam paper, you'll be have two sections, right? One A, B, C, and you'll have two A, B, C, right? And there will be an or in between. Okay. So to score, you need either attempt this one or this one, right? So I'll be choosing the first one. Okay. In most cases, in the first three questions which are there, there will be definitions and the DFA and converting NFA to DFA. Okay. These three types of questions have been asked in single or in most of the repeated questions. And the most important one is this. This has been asked in both the options. Okay, so if you study just this one, it might help you to get 10 to 12 marks. Okay, just alone designing DFA. Okay, so let's get started. The first, you need to know some definitions. Okay, so what a symbol. Okay, in TOC, we will be having symbols. Okay, if you don't know what is a symbol, it is nothing but just a character. Okay, like a, B, C, or any other sign like plus, minus, and multiply, etc. Okay, or any numbers. Everything is considered as a symbol. It is a single, indivisible character that belongs to an alphabet. Okay, what is alphabet is the next definition, but it is a single, indivisible character. Like in the English, we have the letters, right? Like that only in TOC, we'll be using symbols. Okay, this is the exact definition which you need to write. Next is alphabet. Alphabet is a set of finite symbols. You collect some symbols and mark it as sigma is equal to with flower braces the symbols you will put, and that will be called as an alphabet. Now, alphabet can be of different types. If I include 0 and 1, that is binary alphabet because binary numbers have 0 and 1, right? Like that. Okay, what is string? It is a finite set of sequence of symbols. Okay. Now, collection of symbols in flower braces is called as alphabet, but if you use those symbols to form a string, that is called as a string. Okay. Language is a set of strings. Okay. If you have strings like this and you concatenate, put all of them together in one place, you'll call it as a language. Okay. For example, A, B, A, B, A, B, where string length is odd. So this is all the strings where the string length is odd. Okay. But A is not odd. So forgive me for that. But the language means a set of strings collected together. Okay. Next definition is concatenation of languages. Combining two or more languages. Now, language means a set of strings. If you combine two set of strings or two languages, that will be concatenation of languages. That means if L1 is 1, 2, 3, 4, and L2 is nothing but 11, 22, 33, 44. If you do L1 dot L2 become 1, 11, 2, 22, 3, 33, 4, 44. Means all of this will be combined. Okay. Next is power of an alphabet. Power means if sigma is here and star means everything. Okay. And another definition which you need to know, star means all and plus means except zero. Okay. Except zero means one or more. Okay, this one you will get to know when I will be solving the questions. But for now, what is the power of an alphabet means? Suppose that there is a binary alphabet which is 0, 1. Okay. Now, the sigma power 0 means a string of length 0. 0 length means it will be empty set. Sigma 1 means string of length 1. Length 1 means what will be the characters inside that. It will be 0 and 1, right? Now, suppose that we'll be putting 2. Okay, 2 means string of length 2. Power 2 means string of length 2. So it will be 0, 0, 0, 1, 1, 0, 1, 1. Means all the combinations with 2 length. Okay, that is the power of an alphabet. Okay, so sigma star means all the possible combinations, whether 0 length, 1 length, 2 length, 3 length, till n length. Okay, that is the whole combination is sigma star. Okay. Next is reversal of a string. It is an operation in which the order of symbols is in a reminder string is inverted. For example, if W is a string which is A1, A2, A3 till AN, then if you reverse it, AN will come, then AN minus 1, AN minus 2 till A1. So if you have like A, B, B, A, B, in that case, reverse this will be B, A, B, B, A. Okay, like that. And you'll be denoting the reversal by W raised to R. W is a string means W raised to R will be the reversal of it. Okay. So this was about the definitions. Now, after you have got to know about the definitions, you need to learn about the most important topic, which is designing DFA. Okay. First, definition of DFA you need to know. DFA is DFA or DFSM, deterministic finite automata, or SM means state machine. Okay, both are interchangeably used. A DFA is a five tuple or quintuple M, which includes Q, sigma, tau, Q naught, and A. Okay, where Q is a non-empty finite set of states, means all the states will be present in Q. Sigma is a non-empty finite set of input alphabets. Whatever the alphabets I have told, right? The alphabet was your binary alphabet, which includes 0 and 1. Those alphabets are nothing but a set of means alphabet input alphabets. Okay. Next is tau. Tau is a transition function, which is a mapping from Q into the alphabets, the states with alphabets cross connection to Q. Okay, this one just learn as such because you can't alter these things, but in the problems you'll understand what these terms means. Okay, and Q naught is the starting state, and A belongs to Q naught is the set of accepting or final state. So in DFA we'll be having a starting state and a final state. Okay, that I will be discussing in the basics. Okay. Or if you're aware of how these things work, what is DFA, you can listen to this. Okay, it will be a good revision for you. Now, in DFA, we have states. First of all, if they ask you to design DFA, okay, you need to know you have to make states. Okay, states means it will be like this. Okay, Q naught will be written and a circle will be made. Q1 and circle. Like that, how many ever states we want, we can make. Okay. And we move from one state to another state. Means Q naught to Q1 we move, Q1 to Q3 we move. Like that, we'll keep on going. Okay. And if you observe, there is a double circle here. What does this double circle mean? First state is the starting state. This is called as starting state. Okay, you'll be starting from here and you will be reaching to the double circle. Okay, where you will be starting from? You will be starting from the starting state here and you will be reaching the end state. Okay, that is the final state. And final state, it will be marked with double circle. Okay, we move from one state to another based on a rule. There will be some rules. Okay, for example, let's take an example of string AB. Okay, string AB if we take, if I'm moving from Q0 to Q2. Okay, let me correct this one. It is not exactly like this, or else just ignore. I'll be telling you what it actually means. See, if you move from one state to another state on a string. Okay, let's take this example only. String ABBA. Now you will be asked to represent this using DFA. So first step, what you need to do is how many letters are there? Count 1, 2, 3, 4. So four circles you have to make. 1, 2, 3, 4. Okay, you can start like this. Make an arrow and a circle Q naught. Then you will be making an arrow on which it goes from A. First letter, it goes to the next state which is Q1. Then the next letter which is B. From B it goes to Q2. From there it goes to Q3. Then from here it goes to A. The last one, wherever the last one goes, it will go. It will go to the final state, which will mark with double Z. Okay. If we take an example of BABAA, in this case, the starting state will be this. You will not mark B here. Okay. After the starting state only you have to mark. So it will be BABAA, and this will be the final state. This is how you convert a string to DFA. Okay. If you have understood this much, we can proceed further now.
Okay, so the first question which is present is draw DFA to accept strings of A's having at least one A. Okay, so the first thing which you need to do is write the alphabet. Okay, so the alphabet in this case would be just A because they have given strings of A's, right? And language would be what all the strings you can form using A with the condition of having at least one A. Okay, so the strings which you can form is the least string is A. After that, you can have double A, triple A, any number of A's, right? That are the valid strings. So this forms a language. After that, you need to make the DFA for a minimum string. Okay, first step is to make the DFA for a minimum string. Minimum string is A. To make the DFA for A, make the starting state here. After that, it will be passing through A here and it will be reaching the final state here. Okay, that's all you need to do. But after that, for each state, you need to define all the letters are having the transition function or not. That means for Q0, I have a transition function for A, but Q1 I don't have, right? I have just made Q0, A and Q1. So I can have n number of A's after that also, like in the self loop, right? So I will be making a self loop with A. Okay, so that is what draw DFA to accept strings of A's having at least one A. This much only if you make, you will be easily able to score the marks. Okay. Next is draw DFA to accept strings of A's and B's having at least one A. At least one A means zeros A's are not accepted. At least one A should be there compulsorily. Okay. So here the strings are A's and B's. So the alphabet will be A, B, and here we'll be having the language. Minimum string is at least one A, right? So we'll be having A, and after that you can have B and A anywhere any number of times. So starting part, just take care of the bare minimum string. For the bare minimum string, you'll be making this one here Q0. Okay, Q0, and you'll be having A here, which is going to the final state Q1. Okay, that's all you need to do. After that, you need to check for each state whether A and B are defined or not. For this state, A is defined but B is not defined. So I can take a self loop. Always you have to check if you can first take the self loop or not. Here I can take the self loop because it doesn't make any difference. I can have n number of B's. Then if I follow from A, I'll reach the final state. Okay, before going through A, I cannot reach the final state just by taking B, right? That's why it's valid. I can take n number of B's and followed by an A, reaching the final state. And here, after I reach the final state, my condition is satisfied, which is at least having one A. So I can have n number of A's and B's after that. Okay, so this is the DFA for this question. Next is draw DFA to accept strings of A's and B's having exactly one name. Okay, same question, just that it is having exactly one A. Here n number of A's are accepted, here only one A should be accepted. So the same thing, take care of the bare minimum string which is Q0, it will go through A, to Q1 it will go, and after that B will be present as usual. Here also B will be present, but exactly one A means you cannot have here as A. Okay, you cannot have a self loop on A. Why? Because if you have a self loop means it will be more than one A. So after this case also, if you have an A encountered, you have to take it to the dead state. Okay, dead state means it will be not accepted. Whatever comes and stops here, that only will be accepted. Okay, if another A comes after this point, it will go to the dead state. And we have to define A for this one also. Why? Because for each state, you need to define if, whether both the letters have the transition function or not. For this, transition function for B was present, but for A, we have to make, and it will be the dead state. Okay, and here also you need to make A and B. Moving to the next question, we have draw DFA to accept strings of A's and B starting with AB. Okay, means starting letter is AB, the least string will also be AB only. Okay, now if the least string is AB, you'll start from Q0, you'll take A like this, Q1 you will go, and from here you'll take B and you will reach the final state. That's all we need to do. Next, take care of all the letters if it's there in all the states or not. In this state, A is present, but B is not present. Okay, now let's think about B. It should start from AB. So in the first place only if I get B, I'll go to the dead state because there is no other alternative. I have to go to the dead state if it starts from B. Whereas after going to this state, if I again encounter an A, means A after A, that should not be the case because it should start from AB compulsorily. I cannot have any excuse for A. So if an A comes after the first state, that means it should go to the dead state. Now, the only possibility remaining is A, B, which reaches the final state. And once it reaches the final state, I can have a number of A's and B's in the self loop. Okay. Draw DFA to accept strings of A's and B's ending with ABB. Okay. To end with ABB, first one, what will be the minimum string? Obviously, it will be ABB only. And since it's ending with ABB, before this, I can have any number of A's, or I can have B's, or I can have any combination of A's and B's. Okay. So let's make the minimum string here. Take the Q0 from here, A to Q1, B to Q2, another B to Q3. Now what you need to do? you have to fill the other letters, which is A and B for each state. Okay, currently we have A, B, and B. That's all. Now, this B will be the self loop because it doesn't make any difference. I can have n number of B's followed by ABB, right? And in Q1, I can have n number of A's followed by BB. Why? Because if I have n number of A's, again it will end with ABB only, right? And for this one, A will be taken here. Okay, why A will be taken here? Because if I take A as self loop, what will happen? BAB will be accepted. That is not valid, right? So A has to come here. So from here again ABB will be accepted. Okay. Now at the final point here, after reaching the final state, if again A or B comes, what is my thing to do? What I have to do is I have to take A back to this place from where ABB is coming, right? If I take A here, it will be ending with BB. If I take A here, it will be ending with AB. Okay, that is a wrong. It can end also with AAB, like that. It will end with wrong. It should be ending with ABB, right? So I'll be taking A here. What about B? B, can I take a self loop? No, I cannot take a self loop. Why? Because if it's ending with ABB and I take a self loop B here, someone will come and type BBB. So it will be ending with BBB. That is not the right one. So what I will do, I take B to the place where it is starting. Why? Because I cannot take anywhere in middle. If I take anywhere in middle, this A will be skipped. If I take here, it will be double B. If I take here, it will be 3B. So I have to take from here only so that after all the B's which I want, I can end with ABB. So the criteria will be satisfied. Okay. The next question, draw a DFA to accept strings of A's and B's having substring AAB. Okay, substring means the string inside a string. Okay, means what will be the minimum string in this language? It will be AAB only. Why? Because substring AAB is the minimum string which we have. And after that, before AAB, I can have something, or after AAB, I can have something, or in between A and B, I can have something. I can have B here, or I can have A here, anything I can have. Okay, so substring, the minimum string I have to take here AAB, so I'll be making it very simply. Q0 goes to Q1 on A, Q1 goes to Q2 on A, and Q2 goes to Q3 on B. So AAB is present here. Okay. Next, B will be taken as self loop here. Okay, because this criteria is substring AAB. Okay, so initially I can have n number of B's, that doesn't matter. Next is from here, can I take n number of B's here? No, I cannot take. Why? Because it will become then A, B, A, B. That is the wrong one. So I cannot have self loop. So B, I have to take it back here to the previous state. Okay, first check if self loop is possible. If not, take it back to the state and check if that's possible. Okay, next here I have a B here, but A I can take a self loop. Why? Because already if you reach here means you have already encountered AA, and after that n number of A's does not matter because two A's are already present. After that n number of A's followed by a B, that means two A's will already be there, right? So I can have a self loop for A here and then followed by this. Now once I reach this point, my criteria is satisfied, which is having string AAB. So after that, I can have n number of A's and B's in the same place. Okay. Moving on to the next question, we have draw a DFA to accept strings of A's and B's which do not end with ABB. Okay, so this is a slightly different type of question if you observe. It's saying do not end with ABB. Okay, so to solve this type of questions, you do not have to follow the same method which I told you. One difference you have to do here. Okay, see, make a DFA of all strings ending with ABB. See, the question is you have to form a DFA which does not end with ABB. Your first step would be to make the DFA which ends with ABB, then change the non-final states to final states, and then make the final states to non-final states. Let me explain what I mean. Okay, so you can take the characters which are given here, except strings of A's and B, so the alphabets will be AB. Next, language where the strings end with ABB. That one you have to make. Okay, so ending with ABB, the least string will be ABB, and before ABB you can have A, B, or any combination of AB. Previous question, what we did, the same thing is present here. Okay, after this what you have to do is just erase this, okay, the final state, and make the other states as final states. Okay, if you make these three states as final states and make this as non-final state, that would be your final answer. Now if you observe, this DFA was for the for the strings which end with ABB. Okay, because it's ending in this final state. Now what you did, reverse of this. The reverse of this means whichever strings were ending with ABB, those will not be accepted and rest of the strings will be accepted, which means all the strings which do not end with ABB will be accepted. This is how you solve this type of question. Okay, if you straightly come and try to follow like accepting strings do not end with ABB, that will be very difficult. Follow this method. This is the shortcut one. You will get full marks. Okay. Don't think marks will be good because this is the method to solve that. Okay. Next, draw DFA to accept strings of A's and B's such that there is a language given in which starting is A and ending is A. In between, we have W. W means A and B is present, raised to N. N can be greater than or equal to 0. So, if N is 0 means you can have 0 A's and B's. If N is 1 means you can have either A and or B. If N is 2 means you can have either A or B, or both we can have, like that. Okay. So, what is the least string? If N value is 0, that is the least string, right? 0 means W will not be there, AA will be the least string. So here we'll be writing AA and we'll be making the diagram for it. So starting will be here, Q0 it will come. Okay. From Q0, A it will come to Q1. From Q1 again A it will come to Q2. Q2 will be the final state. Okay, that's all we are concerned about. Next step is to ensure the other letters which are present, which means B. A and B are present. Transition functions are present for A and B in all of these. Means Q0, Q1, and Q2. How do I ensure that? Check for each. Okay. Now the condition here is starting with A and ending with A, right? Starting with A and ending with A. Now what we have to do? Starting with A means if starting only B comes, it should go to the dead state. Okay. And after this A and B is defined, come to the next one. A is defined here. B, what you can do? See, starting with A, that condition is satisfied. And in between there is W. This is the place where W is there. In W, you can have a number of A's and B's. So A is already defined. Just care about B. Make a self loop. You can have a number of B's. After that, you can go for A to the final state. Now, in the final state, also I have to define A's and B's. Okay. Since it's ending with A, I can have the self loop for A and number of A's. But what if B comes? B comes means it should not go to the dead state. Why? Because after B again A can come, right? So B comes, I cannot make a self loop because it will end with B. Can I take it back to this point? Yes, I can take back, because if I take back here to Q1, again from Q1, A will be there and ending will be on A, right? So that's how you will be making this DFA. Next is draw DF to accept strings of zeros and ones for the given language. Here we have W, which is such that 0 0 is present and 1 1 is present, and in between we have 0 and 0 or 1 n number of times. Star means 0 or more. Okay, you can have no 0 and 1 in between, or you can have more than 1. Okay, so the least string would be 0 0 1 1, as it's obvious. If we take this as 0 means it will get cancelled. 0 0 1 1 will be present here. Next will be in between 0 0 1 1 we can have a 0, or in between 0 1 1 we can have a 1, or in between 0 1 1 0 0 and 1 1 we can have a 0 or 1 here, any combination of 0 or 1. Okay, now the least thing is 0 0 1 1. That's what I'm concerned about. 0 0 1 1, done. After that, check for 1 here. Can it start with 1? No, so it will go to the dead state. After 0, from here, can it start with 1? No, it should go to the dead state. From here, 0 and 1 is defined, 0 and 1 is defined here. Okay, 0 0 is done. Now I can have a number of zeros and ones. Since 1 is already defined, I'll take a self loop on 0. That is done. I'll come here. Here, it should end with 1 1, right? This is the point where it is ending with 1 1. So 1 is defined here. I have to have a 0. Okay, so this self loop will not be present here. Let me just correct that. See, this self loop will not be present. Why it will not be present is because already 1 is defined from here. I cannot have another 1 here, right? I cannot have another 1 here because in DFA only one time it will be. Okay, you cannot have two transition functions for the same value. Okay, you cannot have two transition functions. If you have already for 1 here, you cannot have again for 1 here. Okay, like that you cannot do. So here 1 will be there, and if 0 comes here, I cannot take in between as 0. I cannot take like this. Why? Because if I take 0 here, it will be ending with 1 0 1, and that is invalid. So I'll take 0 here. Okay, so such that 0 will be coming here, and after that 1 1 it will be ending, and at the end it's ending with 1 1. I can have a number of ones here, but if it's coming as 0, again 0 will be taken to this state, after which it will end with 1 1. Okay. Next, draw DFA to accept strings of A's and B's having 4 A's. 4 A's means exactly 4 A's. Okay, so L will be 4 A's here, and before or in between you can have B's also, and number of B's also you can have. Okay, so it's very simple. 4 A's is minimum. Make 4 states here. A, 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 A. Final state you have reached. Now we have to define B. In between all of these case, you can have n number of b's, or you can have 0 b's also. So make a self loop. If you want, you can take this, move to the next, take here also b's, or you want to take here also b's, you can take b's here also. And once you reach the final state, you can have n number of b's. But after reaching the final state, your 4 a's are completed. You cannot have any other a. If any other a comes, it will go to the dead state. Okay. Next, draw DFA to accept strings of zeros and ones, zeros, ones, and twos beginning with a zero, followed by odd number of ones and ending with a two. Very simple. You have to start with a zero, full. Odd number of ones, it can have 1 time 1, it can have 3 times 1, it can have 5 times 1, and so on, and ending with a 2. Least string is 0, 1, 2. I'm concerned with that. 0 will come here, 1 will come here, 2 will come here, it will go to the final state. Now, it can have n number of ones also, right? But before that, if it starts from 1 and 2, it should go to the dead state. In between, if it comes 0 and 2, before the ones are over, or in between the ones, if 0 and 2 come, that should also go to the dead state. After 0 1, again if 0 comes, that should also go to the dead state. And when 2 comes, it will go to the final state. After it has reached 2 here, again if any other 2 will come, if any other 1 or 0 will come, that should also go to the dead state, because ending with R2, single 2 it should end. After that, if anything comes, it will go to the dead state. Now, having odd number of ones, how can you ensure that? See, one will be coming here. Okay. Now again, if you have to have triple one, triple one means again you can come back here one, and again you can come back here. So here it is 1 1. Okay. And if you want to make it 3, pass from 1 2 more times. That means go and come back, it will become 3. Again go and come back, it will become 5. Again go and come back, it will become 7, and so on. So this will always ensure it is odd. Okay. So like that, you have to go back. How do you get to know if you have to take back or not? The rule is, first you have to check self loop. Self loop is not valid, go and check back state. If it's not valid, go and check the next back state. Like that, keep on going. You'll get one of them correct one. That one you have to keep it. Okay, like that you have to approach. Okay. Next is construct DFA which accepts a language of all binary strings divisible by 3 over 0 and 1. That means whichever binary strings are there, like 000001010 and so on. Okay, whichever binary string is divisible by 3, which are divisible by 3, 0 is divisible by 3, 3 is divisible by 3, 6 is divisible by 3, 9 is divisible by 3, 12 is divisible by 3. Okay, all those strings should be accepted, rest all strings should be rejected. Now, what you have to do in this type of questions where it is divisible, okay, this is another type of question where divisibility will be there. There you have to see which all reminders are possible. So for 3, what all remainder can be possible if you divide? 0 can come, 1 can come, and 2 can come. Now, if it is 0 means 0 remainder, 1 means the remainder will be 1, 2 means the remainder will be 2, 3 means remainder will be 0, 4 means remainder will be 1. Like that, make 3 or 4 columns. Okay. After you have made these columns, you'll get an idea. Okay, since they have asked in binary, you have to write the binary equivalents of this also. Now, after you have done this much, for each remainder there will be one state. Okay, this is the method you need to follow. For each remainder, you need to have a state. Okay, so remainder 0 take Q0, remainder 1 take Q1, remainder 2 take Q2. Now, for each state, you will be starting from the starting point. Now see, starting point start from the first number, which is 0. Okay, this is the starting state, and 0 is the means final state. Also means if it is empty string also, that means it will be 0 only, right? So it will be the final state here, and n number of zeros you can follow, that will be accepted here. Okay, now after that, if it is 1, okay, means you will be taking it to 1 here. 1 means remainder 1. Okay, see, what I mean is, this is 0, you will take 1 0 and you will take it as 1 here. Now 0 1 is nothing but 1, right? 1, and that is reminder 1, and that is q1. So that's why it is taken to q1. Okay, now what about 2? 2 is 0 1 0, so I'll take as 0 here, and I have taken as 1 here, and if I want to take again as 0, I'll take it to q2. Okay, so first make q0 q1 q2, and based on that, whether you have to take 0, whether you have to take 1, see this table. 001 is going to q1, 010 is going to q2. Okay, like that you have to see and make all these until you reach 11, or if you reach 9 also, you will be able to fill this whole thing. Okay, now see, 0 is defined here and 1 is defined here. Q0 task is done. Now for q1, Q1 only 0 is defined, right? We just have come from 0 here. What about 1? 1 means come here as 1 and go back to 1 here. Okay. So if it is 0, 1, 1, just see 0, 1, 1 where it is lying. 0, 1, 1 is lying in Q naught. So from this point, you have to connect to Q naught on 1. I'll repeat. See, at this point, we have right now only 0, right? Now we have to define for 1. Define for 1 means I have come here through 0 and 1, and I have to define for 1. That means 0, 1, 1. Now check 0, 1, 1 where it is. It is in reminder 0, which is Q naught. So 0, 1, 1 will be corresponding to Q naught. Okay. And finally from here I am going through 1, right? So it will be 0, 1, 1 through Q naught. Okay. Like that. So 0 and 1 is defined for this. Now define 0 and 1 for this. Currently nothing is defined for this. Okay. Now what if it is 0? What if it is 1? Okay. If it is 0 means what will be the number? The number will be 0, 1, 0. Okay. What will be 0, 1, 0? Which number it is? Where it is in this column? 0, 1, 0 is this one. Right. 0, 1, 0 is 2. So 0, 1, 0 is 2. I have reached here. Now after 0, 1, 0, if I again want a 0 or 0, 1, 0, 1. Okay, means 1 and 0 I needed the end for this. Till here I have reached through 0, 1, 0. After that I want what is 0, 1, 0, 0, 0, 1, 0, 1, where it goes, right? So 0, 1, 0, 0 is nothing but 4, 0, 1, 0, 1 is nothing but 5. Okay, just add a 0 here. That it doesn't make any difference. 0, 1, 0, 0, 0, 1, 0, 1. So for 0, 1, 0, 0, it should go to Q1. So 0, 1, 0, 0 means when it goes to 0, it should go to Q1. Okay. And 0, 1, 0, 1, which is this case, if it is 1, at this place, if I want to do it for 1, it should go to which one? It should go to Q2 only. So it will be a self loop for Q2. Okay. That's all you need to make. This is the final answer. So if you want to check, for example, 10, 10 means 1010, right? So let's take 1010. Where it is in Q1. Q1 means remainder 1, and that is correct. If you divide 10 by 3, it will be remainder 1, and that will not be accepted. Unless and until it is divisible by 3, then only final state it will come and it will be accepted. Got the point? Next. Construct a DFA such that number of A's in W mod 3 is equal to 0. Means how many A's are present here? That should be divisible by 3. Okay, so let's have what will be the minimum string? Minimum string would be 0, null string. Because null string means 0 is divided by 3, that is also 0 only. Right, so least string will be the means null string would be the minimum string. So you can have the starting state and the final state same, because nothing also if you do it will be accepted. Okay, next, what would be the next thing which will be having the least string? We can have n number of b's along with 0 a's, right? N number of b's along with 0 a's, all those are accepted, so there is a self loop for b. Next is at least 3 a should be there, right? So first a it will go to q1, second a it will go to q2, third a it will come back to q0, so it will be accepted. Again, if you repeat another 3 times, it will be there. It will always be mod 3 0. Okay, and in between you can have n number of b's as self loop. It doesn't matter because the count we are taking is of a's. Okay, now obtain a DFA to accept the string w satisfying the following condition. Here we have w mod 3 is greater than or equal to w mod 2. The length of w, if you divide by 3, what remainder you get, that should be greater than or equal to the remainder you get when you divide by 2. And it's very important question. Okay, it has been repeated a lot of times. Listen carefully. Okay, where the w is having just the symbol a. Okay, now see, if w is empty, length of w will be 0, right? So if it is 0 means 0 mod 3 will come here and 0 mod 2 will come here. Whether this is true or not, 0 mod 3 is 0, 0 mod 2 is 0, and 0 is greater than or equal to 0, it is accepted. Means empty string is accepted, means with 0 a's. If it is single a, that means the length of w will be 1. And 1 mod 3, 1 mod 2, it is both is 1, it is also accepted. What about 2? If there are two a's, 2 a's means length will be 2, and the 2 mod 3 is 2, and 2 mod 2 is 0. Right? 2 mod 3, if you divide 2 by 3, it will be 2 remainder, and if you divide 2 by 2, it will be 0 remainder. 2 is greater than or equal to 0, yes, this is accepted. What if it is 3? 3 mod 3 is 0 because 3 is divisible by 3, the remainder will be 0. 3 divided by 2, the remainder will be 1. 0 is greater than or equal to 1, it is not true. Like that, you keep on writing for 4, it will be 4 mod 3 and 4 mod 2, 5 mod 3, 5 mod 2, 6 mod 3, 6 mod 2, and so on. Okay. And once you observe till 9, if you write, you will have two places where it will not be accepted. Means the condition is not getting accepted. So what do you observe? 3 is a multiple, 9 is a multiple of 3, but it is odd multiple of 3. So odd multiples of 3 such as 3, 9, 15, 21 are not accepted. This is the rule you need to find out after writing this observation. Whenever the mod question comes, just write from 0 to 9 what is the answers you are getting and which cases it's getting accepted, which cases it's getting rejected. After that, since we have two mods, you have to make two DFA. Okay, see, two mods are given, right? So you have to make two DFA. Okay, and merge them. So how you will make the DFA? So mod 3, what will be the DFA? Mod 3 means when it is divisible by 3, means either 0 letters, 3 letters, 6 letters, 9 letters, it will be divisible. This language will be accepted. So mod 3, it will be like this. Q naught will be here, which is the final state, and after that 3s will be there, again 3s repetitively. Okay, so it will be in this format. Okay, that is mod 3. Mod 2 will be just a and another a, even, another even, another even, like that. Okay, and null will also be accepted. Now you have to check how many group reminders we have got. See, for 3, how many reminders you can have? 0, 1, 2. For 2, how many reminders you can have? 0 and 1. So combine all of this, 0, 1, 2 and 0, 1. You can have 0 with 0, 0 with 1, 1 with 0, 1 with 1, 2 with 0, 2 with 1. Right? So you can have all of these numbers. Now, if you check in 0, 1, it will not be accepted. Okay, if you observe here, in which case it was not accepted. When it was 0 and 1, when mod 3 was 0 and mod 2 was 1, it was not accepted. Here also mod 3 answer was 0 and remainder was 1, it was not accepted. So we can form a rule that whenever the remainder of 3 is 0, whenever the remainder of 2 is 0, when they occur together, it will not be accepted. Rest of the cases, all it is accepted. Okay. Now you have made this, all you have to do is mark each of these as one of the state. Like this will be q naught, this will be q1, this will be q2, and so on till q5, I think, right? So q5, we have marked this, and once you transition on a, means if you are in this state, if you transition on a, which state you will be reaching? How do you find out which state you will be reaching? You have to see the previous DFA. Okay, see, the first one is for mod 3. Okay, mod 3 reminders, and second one is mod 2 reminder. Okay, now mod 3 reminder, mod 2 reminder. In mod 3, when it was 0 and it goes on A where it was reaching. Go and check. In mod 3, when it was 0, it goes on A, it was reaching 1. Similarly, when mod 2 was there, it was on 0, it goes on A, reaches 1. So, from 0 and 0, it is reaching 1 and 1, right? The same thing we will be writing here, it is reaching 1 and 1. Like that, you will check when it is 0 and 1 for. Like that, similarly, you will check when it is 0 and 1 for 3 and 2, 0 on A where it goes, 1. 1 on A where it goes, 1 on A. 1 on A, it goes to 0 in mod 2, right? So you will be writing 0 here. Okay. Like that, you will be writing for all of these, and you will be corresponding it. 1 1 means Q3, right? Because we have mentioned 1 1 means Q3, so you'll be writing Q3 here. 1 0 is what? 1 0 is Q2, you'll be writing Q2 here, and so on. After you have done all of this, which state is not going to be accepted? This state is the one which is not going to be accepted. Okay, in final state, after it goes to A, 0, 1 is not going to be accepted. Rest of the states are accepted, means it will be the final state. So the only state which will not be the final state is Q1. So the same thing you will write Q naught to Q3. Okay, it is going on A. So Q naught to Q3, it is going on A. From Q3, come here and see where it is going. It is going to Q4. So Q3 to Q4 is going on A. From Q4, where it is going to Q1. Q4 is going to Q1 on A, but it will not be accepted, so it will be just a single. Next, again, Q1. Q1 is here, Q1 is going to Q2. Q1 is going to Q2, it will be double state. Q2 is going to Q5, Q5 is going to Q0. Okay, if you observe this table, you will get that answer. Okay, so this is the final diagram you have to make. Little bit complex, but it's carrying heavy marks. So if you can do it, just practice it once and go. There is a chance that this can be asked in exam. Okay, but if you are feeling it overwhelmed, you can go with the next questions also. Okay, next. strings of A's and B's that contain not more than 3 B's. That means it can have 0B, it can have 1B, it can have 2B, it can have 3B, but it cannot have 4B, 5B, or more than that. Okay, so the least string will be the minimum string. So the starting state itself would be the final state, and here you will be having n number of A's, because A is not our concern here. Our concern is not more than 3 B's. So you can have first B, that will also be accepted, second B can also be accepted, third B can also be accepted, but if any other B comes, it goes to the dead state, and you can have n number of A's in between. Okay. Next, no two consecutive characters are same in W. Means you cannot have AA, you cannot have BB. Okay, in between you need to have some other letter. How do you do that? What will be the minimum string? Since it is star here, that means null string can be taken 0 characters. So starting state itself would be the final state. And what will be the other strings? It can be A, B, because the condition is no two consecutive characters are same in W. A, B are single characters, that is valid. A, B is also valid, B, A is valid, A, B, A is valid. Okay. So now if A comes, it is going to Q1, it is valid. B means it is going to Q2, it is valid. Right? Both are final states. But you cannot have uh, an A upon A, so it goes to the dead state if it happens. You cannot have a B upon B, it goes to the dead state. Okay, so our conditions are eliminated. Now the possibility remains. What if it is A B A B or B A B A? So if it is A B, come to this state. If it is B A, come to this state. Okay, because it is altering. You cannot have consecutively. See, A came here. Next is option is only B, and once you come here, the next option is only A. If you take B, you'll go to the dead state, and if you take A, you come back here. So it is alternating, right? And same goes for the B also. If you come here, the only option is to take A. If you take B, you'll go to the dead state. So if you take A, your only option is to take B again. If you don't take B, if you take A, you'll go to the dead state. So you'll take B here. So it will be alternative, like that. Okay. Just make these states first and then think, can you make a self loop? If not, can you point it to some other nearby state or not? Or if nothing happens, make it to the dead state, like that. Okay, that should be the approach to make DFA. Okay, next. L means the language is given as for 0 and 1 star. W has even number of zeros and even number of ones. So what will be the minimum string? Minimum string would be null, right? Because 0 number of s and 0 number of is both are 0. 0 is the even number. Got it? So you'll be having the null here as the minimum string. What is the further strings? 0 0 you can have means two zeros and 0 ones, because 0 ones is also even number of ones. And similarly, you can have two ones and 0 zeros. 0 zeros is the even number. You can have two zeros in between one, or you can have alternative one, but the total number should be even numbers and even zeros and even ones. Okay. Now, since it is null, means the starting state itself would be the final state. Okay. And from here you have to move very carefully. Now, what is the next thing which is minimum string which can be accepted? 0 0. So 0 will come here, and again 0 will come here, it will be accepted. You cannot make a self loop because it can accept three zeros then if you make a self loop. Okay, that is the invalid. Even number should be there. That's why you have to go to Q1 and then come back to Q0. Then 1 1 is also there. You can come take 1 and you can take back here. You cannot make it as 1 and you can make it as 1. Why? Because what can happen? 1 and 0 will come. So that is not accepted. That's why you have to take it separately. Okay. Now 0 0 is done, 1 1 is done. What about the combination like 0 1 0 1, like that? So in that case, see, after 0, you have defined for 0 here. What about 1? If 1 comes, take it into a separate state. Okay. See, what if the question can come? What if you will take the same state as here? If you take the same state as here, that is fine. But what will happen? 1 0 you have taken, then you will take as 1 here, and you will take as 1, means double 1 is fine, but 1 0 is present. You have to make the combination of this also, right? You have to take care of that. So if you take a 0 here, you have to ensure you pass through 0 again. So that's why you cannot directly take 1 here. You will not pass through 0 again. So instead of that, you can take 1 separately here, so that you have a single 0, single 1. Now you can make the complementary of it, another 0 from here, and 1 is already present here. Okay. Moving in this direction ensures the exchange of zeros. Moving in this direction ensures the exchange of ones. That is how the question is designed. Okay. 0 1 and then again 0 for eliminating this 0 and this one for eliminating this one. Okay, like that. Or you can have it in this way also. 1, first you can come here 1 and then you will take as 0 and you can take as 0, you can take as 1. So 1 0 0 1, or if you want you can take 1 0 1 0. Okay, or 1 0 1, again you can come back here another one, then your choice, you can take another pair of 0 or you can take another pair of 1 and come back. Okay, so it will be working in that way. So it will be like 1 0 1. Okay, 1 is eliminated. If you take back again 1 here, you have to go back here, or if you come back through here, you will be eliminating 1 again here. Okay, so it works in this way. So this is how you write the DFF for even number of zeros and even number of ones. Okay. Next is for every A immediately preceded by and followed by a B. What does this mean? If there is A means there should be a B bodyguard, B for bodyguard. So suppose that there is an A is a girl, okay, and there the girl has two boyfriends, okay, like that. So wherever the girl will be there will be two boyfriends for that girl, okay, like that it will be. So you have to form the DFA for the strings where B is preceded by means A is preceded and followed by two B's. Okay. Now, what will be the least string? If there is no A itself, there will be no B also. It will be empty string. You can have n number of B's also. If there is A means B should be there, starting and ending. But if A is not there means you can have n number of B's. You cannot have n number of B's. Whatever. That all is valid. Okay. And it is star means you can have null also. Null means firstly only you will be having double circle, which is the final state, and you can have a B here which goes to this state, and then you can have a number of B's here. Okay, the question can come, why I cannot take n number of B's here? The reason is, if you take n number of B's here only, and after that if you take A after that, you will be coming here. Okay, see, suppose that if this is your question, n number of B's and A can take here and final state will be here, but n number of B's, it is optional. I can skip this also. If I take it in this way, I can skip this and come with A and go to the final state. That will not be accepted because one B is compulsorily before A it should come. If A has to come here, before that one B compulsorily it has to come. If I make a self loop, that becomes optional. I can skip B also. That is not a valid string. It will accept A also, but it should not. So that's why compulsorily B it should come here. After that you can have a number of B's followed by a, and after A only one possibility remains. You should have a B. You cannot have another A, it goes to the dead state, or in starting only if you have A it goes to the dead state, and from here you cannot take a self loop of B. Why? Because if you take a self loop of B, then how you will go back again to the final state, and you cannot have a final state this, because if you take the final state as this, A will be coming here, it will become the wrong one. Preceded by B means followed by B should happen. So from here only one option remains, come back with B to the final state. Okay, so this is how you solve the preceded and followed by a B. In between A should be there. Okay, now, DFA for decimal strings divisible by 3. The same question which you had did for the binary version of 3. This is the decimal version of 3. Nothing changes. So all what you have to do here is write the letters which are present. See, decimal strings means it can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The valid strings would be like 12, it can be 21, it can be 99, it can be 111. All these are strings which are accepted. So the letters which are there, symbols which are there is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And language would be which numbers are accepted. 0, 3, 6, 9, 12, 15. 21, 20, 24, and so on. Okay, now as I told you, whenever divisibility comes, form the groups of remainder 0, remainder 1, remainder 2. In remainder 0, how many groups, how many letters, how many numbers come? 0, 3, 6, 9, 12. Remainder 1, 1, 4, 7, 10, 13. Remainder 2, 2, 5, 8, 11, and 14. Now, for each of these, form the states. Okay, for remainder 0, state will be Q0. For remainder 1, state will be Q1. For remainder 2, state will be Q2. Okay, now Q naught is present here, you will be taking a self loop 0369. Okay, so you'll be taking a self loop here. Why you will take a self loop here? Because starting state itself is the end state. Because see, if you have 0, it will be the same state only. If you have 3, it will be same state only. And this is the final state. Okay, starting state is final state. Why? Because if nothing is passed also, that is also 0, null string should be accepted. 3, 6, 9, it will be accepting. Okay, so this is Q naught. Q naught is present here. Okay, sorry, not Q naught. This group I can take it as R naught. Okay, this group. whatever the numbers are present here, that will be taken as R0. Okay, I can replace this with R0. That means in this place, whether 0, 3, 6, 9 come, it doesn't matter, it will reach this state only. Okay, let's take 96. 96 is divisible by 3, so 9 will come first, and then again 6 will come first. 96, it's divisible by 3, it's coming here, right? Like that only. If it is, for example, remainder 1 means 1, 4, 7, 10, or any combination of those, like 147, if it comes after from q0, it should come to q1, like that. Okay, next, what about remainder 2, 2, 5, 8, 11, it should go to q2. Okay, 2, 5, 8, those things should come to q2, and the numbers are just this much. Okay, single digits, 0, 3, 6, 9, 147, 2, 5, 8. Okay, now they have passed here. Now, for this state, we have defined the 0369, 147, and 258. All the numbers we have defined. Now, for Q1 and Q2, we have defined the further numbers. Okay, this is very simple. What you have to do is, for this one, what is defined as of now? As of now, nothing is defined, right? Only 147 it came here. Q1 is empty. I have to define 0369, 147, and 258. Let's take the first one, which is 0369. Okay, 0369, what happens in Q1? Okay, let's see. Suppose I started from here, I took a number which is 1, and I came to Q1. After 1, I took another number from here which is 0. Okay, because I'm doing it for this where it has to go, I'll be taking 0. So 1 and 0 means 10. 10 when I divide by 3, where it is coming, how much is the remainder? 10 mod 3. 10 mod 3 remainder is 1. 1 means Q1, right? So it will stay in Q1 only. No matter if I take 0, 3, 6, 9, all will be having remainder 1. If you don't believe, take 16, take 19, or take 43, take 76, take 79. Take 79 divided by 3, it will have the remainder 1, and it will stay in the same. Okay, so just for the one number, if you verify, it will be valid for all the group. That's why I made the groups. Okay, so you got the point, right? From here, if you want to make the group for this one 0369, what I will be doing is 147 is present here, it comes to Q1. From here, if I take 0 means where it is landing, which remainder, that one I will be pointing to. Okay, now like that only for 147, where it will be pointing. Suppose that I come from here and I take 4. Okay, from 4 I am in Q1 now. From Q1 I will be taking one number from here, suppose 7. 47. 47, what is the remainder? 47 divided by 3, the remainder would be 2. Okay, so 2 means if it is 147, it should come to this state. Got the point? If it is 147, the remainder will be 2, it will come to this state. Take any number from this, take any number from this, and find out the remainder. That will be always 2, so it will be coming to this state. Now, what about 258? 258 after 147, let's take 7, and 258, let's take 8. 78. 78 divided by 3, the remainder is 0. The 0 remainder means it should come here. That means 258 all will come to Q0. Okay, so 258, 147, and 0369, based on the remainders what we have got after 147, you have assigned the groups to it. Okay, now like that only you have to do for Q2 also. For Q2, nothing is defined as of now. Take the number 0369, take 147, take 258, and see where all it's going. I'll do it for one. For suppose you came from here, Q2 to Q0 to Q2, how you came? Through 258. Choose one of the number. Let's take 2. 2. After that, 2 0 where it goes, 2 1 where it goes, 2 2 where it goes. 2 0, the remainder will be 2. So, zeros group, it will be a self loop to 2. 2 1, the remainder will be 0 because 21 divided by 3 is 0. So 0 means it should go back here. So 147 group will go back to the Q0, and 258 means the remainder will be 1. Right? 22 divided by 3 is 1. So 2's group, it will go to Q1 where the remainder is 1. Okay, that's how you solve the divisible by 3 problem. Okay. Next is DFA to accept strings of zeros and ones. The language is starting with 0, 1, or 1, 0. Okay, so what will be the minimum string? It will be 0 1 or 1 0, and after that 0 1 0 1 1 0 1 0, we can have n number of zeros and ones after that. Okay, but starting should be 0 1 or 1 0. So minimum string is 0 1 and 1 0. So I'll take two paths because I have two minimum strings: 0 1 final state, 1 0 final state. After that, I can have n number of zeros and one. That doesn't matter because it's just starting with 1 or 0. If it was ending, in that case, I would have been concerned with what I'm doing here, but it's starting means after that point, I'm not concerned. I can do any number of zeros or ones. But there is a catch here. The catch is 0 is coming here, but after this point, you cannot take another 0. Otherwise, if you take another 0 after this starting 0, it will become 0 0 starting. That is not a valid one which is given to us. So 0 cannot be taken in the start. Means 0 followed by a 0 will go to the dead state, or 1 followed by a 1 will go to the dead state. The only possibility remains is 0 with 1 it should go, and 1 with 0 it should go. Okay. So this will be the final state. This is how you solve the DFO to accept the strings of zeros and 1 starting with 0 1 or 1 0. Okay. The next topic is converting NFA to DFA. Okay. So NFA is non-deterministic finite automata. Okay. So it can have epsilon transitions, or it can have multiple transitions, or it can have no transition at all. Okay. So definition of NFA is as follows. An NFA is also a 5-tuple or quintuple M with Q, sigma and tau, Q naught and A. Okay. All of these are same as the previous one. The Q is non-empty set, which is a finite set of states. Sigma is a finite set of input alphabets, and this is the transition function. And Q naught is the start state, and A belongs to Q naught is a set of final states. Okay. Now let's have a look at the question. Convert the following NFA to its equivalent DFA. Okay, so this is the NFA given to us. We have to convert this into the equivalent DFA. Okay, so what do we do here is, first we will construct the table here. Okay, so see, Q naught, when it goes to 0, where it goes, when it goes to 0, it goes to Q naught, right? So we'll write here Q naught. But when it goes to 1, in this case, we will be writing Q naught goes to 1 on Q naught and also on Q1. So non-deterministic finite automata will have both single symbol transitions for both the states. Okay, means Q naught on 1 can go to Q naught as well as Q1. Multiple transitions will be there for the same symbol. So we'll write a group Q naught on 1, it goes to Q naught and Q1. Okay, done. After that, what we have to do, we have to check if any new symbol has come here or not. Q naught is already there. Q naught Q1 is a new thing. So we'll be writing Q naught Q1 here. Now what we will do, Q naught Q1 we will check on 0 where it goes, and Q naught Q1 will check on 1 where it goes. So Q naught Q1 on 0, how it goes is, Q naught on 0 where it goes. It goes on Q naught. So I'll be writing first Q naught here. Then I will be checking Q1 on 0 where it goes. Q1 on 0 it goes to Q2. So I'll be writing here Q2. So combining these both on 0 where it goes, those answers I will be writing here. Okay, like that only I will do for 1 also. Q naught on 1 goes to Q naught Q1, so I'll be writing Q naught Q1, and Q1 on 1 goes to Q2, so I'll be writing here Q2, right? See, it goes on 1 to Q2, so Q2 I'll be writing. Now again we will check if any new group is formed. Q naught Q2 is a new group, as well as Q naught Q1 Q2 is a new group. First we will take this one. So once we take this one, this on 0 where it goes, we'll calculate and keep, that is Q naught. See, Q naught on 0 it goes to Q naught only, and Q2 on 0 it doesn't go anywhere. It is on null. So null and Q naught union, if we do, we will get as Q naught only. We'll keep it as such. Next, Q naught and Q2 on 1 where it goes to Q naught and Q1. Okay, because Q naught goes to Q naught Q1, and Q2 on 1 doesn't go anywhere, so null it will be. So the final answer will be Q naught Q1. Now this is the new thing, we'll be writing it here, and again we'll be checking these 3 for 0, it will go to Q naught Q2, and these 3 on 1 it will go to Q naught Q1 and Q2. Now wherever Q2 is present, it is the final state here. So wherever in the group Q2 is present, it will mark with star, that is the final state. Now make this state Q naught. Q naught you have made here. Okay. After that, Q naught on 0 it goes to Q naught, so make a self loop here, and Q naught on 1 goes to Q naught Q1. So on 1 it goes to Q naught Q1, make it here. Okay. Next, take the next one. Q naught Q1 on 0 it goes to Q naught Q2. So Q naught Q1 on 0 it goes to Q naught Q2, and that is our final state. We'll be making double circle here. And Q naught Q1 on 1 goes to Q naught Q1 Q2, that is a new thing. On 1 it goes to this. So we'll make a double state here, because since it's the final state here. Okay. Next, the same thing we'll do for this. This on 0 goes to Q naught. This on 0 goes to this on 1 goes to Q naught Q1. Okay, means this one. On 0 it goes to Q naught, and on 1 it goes to Q naught Q1, and finally we'll make for this also. On 0 it goes to this state, and 1 it goes to this state. So this is the complete equivalent DFA. Okay. Next, the similar type of question from the previous 2025 paper, January. So convert the following NFA to DFA. Okay, now this is the table which is given. The first thing what you need to do is make the DFA table. This is the NFA table. Okay, see, either they can give you this diagram. From this diagram, make the DFA table like how I explained now, or from this table which is of NFA type, make the DFA table for it. Okay, how do you make the DFA table? The same thing. Okay, let me just change the color of the mark. Okay, see, how do you attempt this question? See here, P, Q, R, S. Okay, now this is the starting state and S is the final state. Okay, now P on 0 goes to PQ and P on 1 goes to P. Okay, so P on 0 goes to PQ, write it as such. P on 1 goes to P, write it as such. First row, you'll write it as such. Then again, the same procedure you will follow. There's a new thing here, P and Q. So P and Q, take it here. Check P and Q on 0 where it goes. How can you check? P and Q both on 0 where it goes? P, Q and R. So I'll be writing P, Q, R. P and Q on 1 where it goes? To P and R. So I'll be writing P and R. And again I will be checking if there is any new. There is a new, there is a new. Two news are there. So I'll be writing those two news and then I will be taking on 0 where it goes, taking on 1 where it goes, and again checking there is another new here. This is fine, this is not new. So wherever I'll be getting a new, I'll be keeping it as such and I'll be finding out on 0 and 1 where all it's going unless I stop finding new things. So when I stop finding new things, I'll be marking with star wherever S is present. Why S is present? S is present. Why I'll mark a star? That is because S has a star here. Final state, whichever group it is there, that will be the final state. And now after this, you already know. Make P from here for 0 and 1 mark to these groups. Okay, for 0 it will go to PQ, for 1 it will be staying in P. Now PQ also do the same thing, PQR and PR, make PQR and make PR, and on 0 and 1 make it 0.2, and then complete it till the last. Okay, so you'll get a diagram like this. Okay, try it from yourself and then compare if your diagram is correct or not. Okay, let's have a look at little different type of question. Obtain DFA for the funny NFA. Same topic only, but a little bit is different here. Okay, I'll be showing you how it is different. Now, they have given a diagram like this. You can directly start from the diagram, but I suggest you first make the NFA table and then make the DFA table. It will be easier. Okay, so steps should be like this. If they give you the diagram, make the NFA table, then make the DFA table. Looking at the DFA table, make the DFA diagram. Okay, now see, NFA table is given, like how we'll create it. First, we will mark as Q0 here. Q0 on 0, where all it's going? It's going to Q0, it's going to Q1. So we'll be writing Q0 and Q1 here. Q0 on 1, where it is going? Q0 on 1, it is going to Q1. So I'll be writing Q1 here. Same thing next. Q1 I'll be doing, then Q2 I'll be doing. And Q2 on 0, nowhere it's going if you observe. So I'll mark it as null here. Okay. And Q2 on 1, it is going to Q2 itself. Okay. Now, NFA table is ready. Make a DFA table. How you will make a DFA table? First, start from here. Q0. Q0 on 0 it goes to Q0 Q1 and 1 it goes to Q1. That same row you'll be writing it first here. After that, observe if any new states are there. This is a new state. So take that new state on 0 where it goes, on 1 where it goes. Like that for Q1 also we had not included. So we'll be including it now. Q1 on 0 it goes to Q2, Q1 on 1 it goes to Q2. Next, this is the new state, this is the new state. We'll be taking these two new states and writing the answers. Okay. And if you observe, we'll be finding out, we'll be arriving at a point where we get Q2 here. So what you have to do, Q2 also you have to take, okay. But Q2 on 0 goes to null and Q2 on 1 goes to Q2 itself. So whenever in DFA table, if you get as null, that state you have to take here. Okay, that is an observation. In previous two questions, this did not take, but whenever you have a in DFA table, if you get a null, take null here, and null also points to both that you have to do. Why? Because in DFA, every state will have a result. So if we don't include this, that means this doesn't have a result on 0. Q2 on 0, where it's going, there is no answer. That cannot happen in DFA. Okay, it happens in NFA, that is allowed, but in DFA it's not allowed. Deterministic finite automata, right? So it should be deterministic result. So we have to have a null, even if it doesn't mean anything. We'll put null here and then null also points here. And this null state will also be explicitly made here. Okay. So it will be like this, start from Q0 and wherever it has the Q2, there all you will be marking as star and that will be the final state. Finally, like this also is a normal state, only Q2 goes to null on 0 and null on 0 and 1, it remains as null. Okay. And that's all for the module 1 of TOC. I hope you found this video helpful and please do like and subscribe. It helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.